Welcome to Pocket Ronnie, where we save your mathematical life.
Okay, in the last lesson we did log functions, but in this lesson we're going to do natural log functions. So let's just say you had log base e of y equal x. So how do you change that into exponential form? Going through the circle motions, it would be e to the x equals y. This would be in exponential form. This is in log form. Well, when you have log base e, someone named that natural log. Well, instead of using NL, natural log, they used LN. And if you look at your scientific calculator, you will see a button that says LN, and that stands for natural log. So instead of using log base e, anytime you have log with a base of e, then it's natural log. So this can be rewritten. Log base e is rewritten as natural log of y equals x. So every time you see natural log, that is an automatic base e. It's an understood base e, it's just not written there. We just use the letters LN to imply natural log. So just to prove, natural logs can be put in exponential form just as log. You go through the same circular motion. So if you had natural log of y equals x, there's this implied base e there, then you can write that in exponential form as e to the x equals y, which is what we just had up here. So I'm just proving to you that this is a log form, or a natural log form. This is exponential form. Anytime you have a natural log here, that's always an implied base e. What is e? E is just a constant like pi. Pi is 3.14159. So the same is true. E is an irrational number, and it is approximately, rounding it, 2.718. So e is a number just like pi, and rounded to 3 decimals is 2.718. Okay? Where is natural log used? Where is this function used? It's used in a lot of science areas. Okay? So now we're going to look at graphing exponential or natural exponential functions, because anytime there's an e in it, that implies, it's a natural log, or we call them natural exponential functions. Why are they called exponential? Because your unknown is in your exponent. So let's just say we had this function f of x equals e to the x. Remember, this is read f of x. We can just replace f of x with y. So essentially f of x equals e to the x is the same thing as the equation of y equals e to the x. We want to graph that. We call this an exponential function. Again, why? Because the unknown is in the exponent. How do we graph exponential functions? Well, the same as if we were to graph any other function or line or circle or parabola. We can do a little XY chart. We pick numbers for x, put it in here, and then find the value for y. Okay? As a reminder, e is 2.718. So essentially what we have here is y equals 2.718 to the x. So we're putting in values for x into here. So if I put in 0 for x, 2.718 to the 0 power. Anything to the 0 power is 1. So now we can put in 1 for x, and I just picked random numbers. You can pick any numbers you want. So what if I put in 1 for x? So I put in 1 right here. 2.718 to the first power is still 2.718. Okay, now let's put in 2. I'm putting in 2 for x. So I'm basically squaring 2.718. That came out to 7.384. And when you're graphing, really you only need to go to 1 decimal place, because you can't really graph to 3 decimal places. Putting in 3 for x. So that's 2.718 cubed. That comes out to 20.086. Now putting in negative 1. If I put in negative 1 right there, what does that mean? That is y equals 2.718 to the negative 1. when your exponent's negative, you have to change the place to make it a positive exponent. Change the sign of the exponent, change the place of the base, meaning move that down. So that becomes y equals 1 over 2.718 to the first power. So 1 divided by 2.718 becomes 0.368. Okay, now we're basically just going to plot these points on our graph. So if I plot these points in our graph, 0, 1, don't go anywhere in the x direction, there's 1. So now 1, 2.718, let's go over 1, up, and all of mine are just estimates. So then going over 3, so, wait, I missed this one. Going over 2, and then up 7.3, over 2, up 7, and again, these are just, I'm just estimating. 3, if I go over 3, I'm up probably way up here somewhere. And then -1, I'm decimal number. You can tell these numbers going in the negative direction are going to get smaller and smaller and smaller. What's going to happen is, going x in the positive direction, these numbers are going to get bigger really quick. This is why it's called exponential. They are getting bigger exponentially, okay? And these numbers are getting smaller and smaller and smaller, but they will never be crossing the x-axis. They will just be getting closer and closer to the x-axis. So exponential graphs are usually curved in some sort of fashion like this. Okay, that was just an example. So now let's look at, in your book, at 22b1. The one we just did was just your basic y equals e to the x. Here we have y equals e to the negative 2x. Don't forget, e is just a number. E is 2.718. So you can replace e with 2.718. How do you make your exponent positive? If you're going to change the side of your exponent, you have to change the place of your base, meaning this all comes down. So basically this becomes y equals 1 over e to the 2x. Okay, so I'm just pick some random numbers for x. Actually, I think they pick them for you in your book. So what if I put in 0 for x? Put in 0 right here. 2 times 0 is 0. E to the 0 is 1. Anything to the 0 power is 1. And 1 divided by 1 is 1. Okay? So now what if I put in 1 for x? Putting in 1 right there. 2 times 1 is 2. E squared, which is basically 2.718 squared. So if I put in that, that would be 1 over e squared. So I'm doing 1 over 2.718 squared. So 1 divided by, essentially what we're doing is 1 divided by 2.718 squared. So do 2.718 squared, 1 divided by that comes out to 0.135. Okay, now let's do 2. Putting in 2 for x, that'd be 2 times 2 is 4. So essentially that is 1 over e to the 4th. So you're doing 2.718 to the 4th power, and then 1 divided by that comes out to 0.018. Now let's put in -1 right here for x. So if I put in -1, 2 times -1, that would give me e to the -2. How do I make this exponent positive? If I change the sign of the exponent, I have to change the place of this. So it's in the denominator, which means I need to bring it back up to the numerator. So essentially I would have y equals e squared. Changing the place of this, change the sign of the exponent. So then that would be 2.718 squared, which would be 7.389. I think I said 7.384 earlier, and it was supposed to be a 9. Couldn't read my own handwriting. And then now we're going to put in a -2. Okay, so putting in a -2 right there. 2 times -2 means -4. So this would be 1 over e to the -4. How do I make this exponent positive? Change the place of the base. bringing the e up, that would be e to the fourth. So 2.718 to the fourth power, 54.578. Alright, let's plot those points. So don't go anywhere in the x direction, go up 1. Over 1 in the x direction, now you're getting smaller numbers. As I go over 2, it's even smaller. In the negative x direction, my numbers are getting bigger and then even bigger. So you can see the pattern. These are going to be getting smaller as you get in the positive x direction, and then as you go in the negative x direction, these are getting bigger. Again, exponential graphs will be curved. Alright, we're going to be graphing 22C, number 2, y equals natural log of x squared. We're going to do an XY chart. I'm not doing all the points that are listed in the book. So the one thing I do want to point out, if you notice, I don't have 0 over here for x. If you were to put in 0 right here for x, 0 squared is 0. Natural log of 0 is an error. If you put that in your calculator, you will get an error. You cannot do natural log of 0. Okay? So you will see after we graph it that x can never be 0, meaning our graph will never cross y will never be 0. Okay? We will never cross the y-axis. So, okay, so let's put in 1. We put in 1 for x. 1 squared is 1. Natural log of 1, this is something I probably would memorize. So, natural log of 1 will always be 0. Okay? Natural log of 1 is always 0. Now putting in 2 for x. 2 squared is 4. Natural log of 4, you can put that in your calculator. Natural log of 4 is 1.386. When you're doing your calculator, when you say y equals natural log of 4, usually you can put in 4, then hit your natural log button, and that will tell you what natural log of 4 is. Some calculators, you have to hit the natural log button first, then hit the number 4, then hit enter. Okay, putting in 3 for x, 3 squared is, and you do your exponent first. 3 squared is 9, natural log of 9 is 2.197. Now, negative 1. So, be careful of this. This is y equals natural log of negative 1. That negative 1 is in parentheses. So, negative 1 parentheses squared, that would be a negative 1 times a negative 1, which is a positive 1. So that is the same thing as y equals natural log of 1. And natural log of 1 is 0. So now we're putting in negative 2. Negative 2 squared is a positive 4. We already found that answer. Natural log of positive 4 is 1.386. Are you seeing a pattern? Then we did negative 3. Negative 3 squared is 9. Natural log of 9. We did that one. That was 2.197. Okay? So this graph is actually going to be a mirror image of itself. So plotting this point at 1, going over 1, didn't go anywhere in the y direction. So that's that. Jump down to this point. Negative 1, 0. Negative 1, 0. 2, going over 2, up 1.4. That's the same mirror image of this. Go over negative 2, up, same thing. Now, positive 3, it's going to be somewhere up in here, and then here. And then, what we're not showing is the bottom half of the graph. But you can actually plot points that are below 1, and in your book it has those. It has like 0.5 and then negative 0.5. So this is at x is 1/2, negative 1/2. What will happen is you'll actually be getting closer to the y-axis. So as x gets bigger, your y's get bigger. As your x's get smaller, your y's get smaller, but you will never cross the y-axis. So it should be something like that, but they're mirror images of each other.